Welcome to Spacetime, Day 2.
This is ground control to Major Tom.
Welcome back to Spacetime, Day 2. Today's topic is wormholes. We're going to discuss how we create them, what they are, and how we can use them in the future. But before we get to that, I'd like to give a quick shout out to two of our sponsors. Our first sponsor is toilet paper. 9 out of 10 bears recommend using toilet paper. Our second sponsor is paper towels for when you run out of toilet paper. Right now you are looking at a theoretical wormhole. We call this an Einstein-Rosen bridge. These are the two scientists who helped discover this theory of wormholes. It's actually mentioned in the second Thor movie. If you remember from our first video, we discussed what spacetime is. Hopefully you can tell that the grid on this image is the spacetime. You should also remember that more mass of an object, the more distortion or warping of spacetime around that object will occur. What would happen to spacetime if we had something with an almost infinite amount of mass? Can you think of what this something might be? You guessed it, it's a black hole. I'm not going to go into a lot of detail about black holes since we have some groups using this as a topic, but very simply, a black hole is a region of space with almost endless amounts of mass. If we have something like this in space, it will actually tear open space-time. What do you think we create when we have a tear in space-time? You guessed it again, a wormhole or a gateway through space-time. If you look at this diagram, you can see the actual tear in space-time. We assume there is a black hole on the top of the space-time grid, where the white arrow is, and it is causing a wormhole to develop. This tear in spacetime theoretically should open up to another part of the universe. With these theories, scientists have calculated that there are technically two ways to travel in spacetime. You can travel along spacetime, shown by the yellow arrows. This would be the conventional way, but would take eons to get anywhere useful. Or you could travel through spacetime, and assuming the theories are correct, come out in another part of the universe. Hey guys, look who joined us. It's Ollie, the Don't Forget to Share Your References Juggling Octopus. How you doing, Ollie? Still juggling? Awesome. My reference is this book, Michio Kaku's The Future of Humanity. It's a great read about the past, present, and future of technology and space exploration, and how they're interwoven together to create what we have today and what we will have in the future. If you have any time on your hands, I would highly recommend reading this book, especially if you're interested in how our humanity is going to change centuries from now. Let's talk about the future of wormholes and how we could use them. We have theorized that at the other side of a black hole, through the tear in spacetime, or the wormhole, is a white hole, a place where all the matter that was swallowed up would go, and all of the light. Why it's called a white hole. Unfortunately, we haven't found any evidence or any in general yet, but we have hypothesized that they could be in a parallel universe. Here's the thing. To go through this wormhole, we need to make sure that it's stable. How do we keep this gateway open and keep it stable once we either find one or create one ourselves? Since the wormhole is going to be created with positive energy and matter from our universe, we would need to create negative matter or negative energy from our universe to keep the gate from collapsing. Negative matter has never been seen, created, or observed in our universe, but we have created negative energy in labs before. So there's still hope for controlling and making a stable wormhole. Unfortunately, we've made a microscopic amount of negative energy compared to the amount we would need to use in a wormhole to keep it stable. So how do we get more negative energy in our civilization to keep a wormhole, if we find one, stable and open for us to use? What we would need to become is something called a Class 3 civilization. So what does that mean? According to a Russian astronomer from the 60s, Nikolai Karshadev, he created this scale of civilizations and the amount of energy they can store and use. There's 3 classes. The first class is called a planetary civilization. That civilization can use and store all of the available energy on its planet. Second class is a stellar civilization. That's a civilization that can use and control energy at the scale of its solar system. So the entire solar system, all the energy we would be able to use and store. The last class, a Class 3 civilization, is called a galactic civilization. That can control energy and use it at the scale of the entire galaxy, which in our case, our host galaxy, is the Milky Way galaxy. Technically, there's a Class 4, and when we go into the multiverse theorem, we would talk about a Class 4 civilization is a civilization that can use the entire universe amount of energy and control it. But we'll talk about that once we talk about the multiverse. As of right now, we are only about a 0.7 class civilization. So we have not even gotten to a Class 1 civilization yet because we still don't use solar, geothermal, hydroelectric as efficiently and as much as we should to become a Type 1 civilization. Who knows, we may start to increase in our lifetimes. That would be super nice if we became a Class 1 civilization in my lifetime and in your lifetime. At this rate, not going to happen. But hopefully in the future we start to see how much we can harness energy from the Earth itself and from sunlight. To become a Class 2 civilization is going to take a couple thousands of years to harness everything from the sun, everything in our solar system. That's going to take a while. If you want to learn more about this, there's something called a Dyson sphere, created by a scientist named Freeman Dyson, and it talks about how we could collect all the energy from the sun. And then Class 3 civilizations is going to be a few 100,000 to 1,000,000 years in the future. Hopefully the human race will survive that long to get to that point, but that's when we can probably start working and trying to use wormholes and making them stable to use them for transportation. Hey guys, look, it's Gary. It's time to wrap up the show Dinosaur. Gary, you're looking the wrong way. No. There you go. Hey, Gary. All right, I guess it's time to wrap it up, huh? So a quick recap. We know now that wormholes are tears in space-time, always associated with a black hole. On the opposite side of the wormhole, we theorize is a white hole where all the matter and light goes out of. We would need to use a lot of negative energy to make that wormhole stable enough so we feel safe going through it. And we would need to be able to control that amount of energy And the only way to do that with the amount of energy we need would be to become a Class 3 civilization, a galactic civilization able to harness the power of our galaxy. So that won't happen for another few 100,000 to 1,000,000 years, but fingers crossed, we will get there. Remember to check the next couple slides for your goals for your own research project for today. Hope you enjoyed the video. We'll see you next time.